Hi everyone, I'm Mariana Tesma Martins. I'm a student of Mechanical Engineer by Federal University of Santa Catarina. I will present the work about assessment of fuel informed by a thermo-oxidative degradation of jet fuel in turbulent flow in a capillary tube. This is a summary. I will start by introduction, then arm of the work, material and methods, result, conclusion, and final reference. The first thing we need to have in mind is that aviation jet fuel is used as a coolant to remove waste heat. It's because the aircraft require intense cooling, so the aviation fuel used and need to have a thermal capacity as an important factor. Thermo-oxidative degradation strongly depends on chemical and physical factors. The physical aspects that influence are time, temperature, pressure, mass, random number, characteristics of the deposit format, and hardness. The chemical aspects are related to composition of the fuel and chemical species that react with the fuel. There's an anomalous relationship between the rate of oxidation and the formation of the deposit. That's relation of the phenols that provide a resin to bind the insoluble materials in the fuel and have antioxidant properties. In this work, we will explore the HIRET test to understand the deposit formation. HIRET is a small-scale test, as Jeff taught test, but uses a turbulent flow. In HIRET, the incrustation grows inside the test tube, and the fuel temperature at the exit of the test section must be kept constant, so the outside tube temperature increased and was resisted by the position and time. The main object of the work is measure the mass and thickness of the deposit layers in the HIRET test as a function of time. The fuel that used for our analysis of this work is aviation kerosene, KAV, that was stored in ambient temperature for 2 years, so the prospect of the test was big pressure of the positive mass due to the degradation in this old fuel. All tests in the HIRET bench use the same gallon of fuel, so it's unique sample of fuel. This slide have the physical-chemical characteristics of the KAV that used in this work. The HIRET experimental bank was a HIRET test equipment with some modification that includes a recirculation line and changes in the acquisition and control system. When the test run, the fuel is pumped at a constant flow rate of 35 ml per minute. The capillary was heated by a Joule heating in the test section to maintain the exit flow temperature constant. External capillary wall temperature was measured by an infrared camera. The capillary used as the original of the equipment. They have a black paint coat to make emissivity equal 1. The capillary, all the tests use recirculation, the same quantity of kerosene and the same time to initial heat. And at the end of the test, the HIRET number is calculated by the equation below. We have two approaches of measurement: the measure of the mass in the microbalance and the image of the capillary in the deposit. For the measured mass, first we remove all the black paint coat and clean the capillary. So the capillary is sectioned in 4 parts and seen for the image below. The adhered deposits were removed by ultrasonic bath for 2 hours, immersed in solution of potassium permanganate. The deposit mass was different between the measurement of the capillary before and after deposit removal. For the characterization of the test capillary tube and the deposit, it was used 3 samples with the same section of the capillary, named section D. That is the same region of the temperature analysis in the HIRET. C2 tests, which obtained as a previous result in the greatest number of deposit mass, was replicated with the same experiment procedure and the same test time, obtained the C5 capillary. Three samples are obtained: C2D, C5D, and C6D, that corresponds to capillary 2, 5, and 6 in the section D, to be analyzed. This sample was embedded in resin and analyzed by optical equipment. We used old tests with the same field, named capillary 0, to generate other images to compare it. In the table below is presented the results of the 4th test of the hierarchy band, and the 5th test was copy of the 2nd test. But C2 has the lowest stability of all samples. In result, the 30-minute test presented instability. From C1 to C4, the hierarchy number are gradually increased and value of C5 is not value close to C2. The possible cause is the variation in internal hugs from capillary to another. Difficult to control the test due to the formation of deposits causing obstruction and pressure variation. The graphic below is from the test that has the highest similarity to the standard test in the literature. Expected that is increased mass in sections A to D. In the 45-minute test, we have the increase of mass in section A to D. Its graphic shows that all capillary sections have solid deposits. And we have two interpretations for the graphics. One is the limitation of oxygen transport to boundary layer close to the wall in the posterior regions, and the second have a deposit displacement by a mechanical action of the flow. This image below shows the results of 3 samples using optical interferometry. The image obtained confused and similar between, because of very irregular characteristics of the inner surface and the capillary wall. The images formed by a light were confused and similar to each other, not allowing to identification the image of the protein referring to the capillary wall or the deposits. The optical interferometry was not effective to measure the deposit thickness. Using a microscopic genolight, it's possible to view the image in colors. In these 3 images, it's possible to compare each capillary sample of the 3 proposed situations. In Figure 1 is unused capillary with no depositions in its interior. In Figure 2, its capillary submitted to 30 minutes of testing and deposit was removed using the methodology discussed. In the Figure 3 corresponds to the 30-minute test with deposit at head. The Figure 3 has a coloration different of the other, showing the deposit at the head. This coloration is similar to the scale of GF Tot. So our conclusions are: the governmental method mass measurement proved to be effective. Measure certainly less 1% of measurement of deposit mass value in 28 mm long section, 1 for the capillary length. Deposit removed by a chemical pickling is effective. Image analysis of the capillary after removing deposit formed in the test shows the same characteristics as a new capillary. Not possible to find values of the thickness of the deposit by an optical interferometry method. Hypothesis is a reflected light in a extremely irregular way, not allowing to measure the interferometry. After 30 minutes, the test shows the presence of insoluble deposits. The image is similar to Jeff Tot methodology, and this color scale would indicate the thermally stable field. In this situation analyzed, the hierarchy number is is the number below. This is the reference is used in the work. And thank you so much for watching this video. If you have any question, please contact me.